The variation of stopping potential V naught with frequency of incident radiation for four metals A, B, C, D is shown in the figure. For the same frequency of incident radiation producing photoelectrons in all metals, the kinetic energy of photoelectrons will be maximum for metal. So here, this point here you see A has a minimum. It has minimum threshold frequency. Threshold frequency. A has minimum threshold frequency. So we know that we know that K max is equal to uh, Planck's constant into frequency by work function. So here threshold frequency is among the three metals. Here A has the smallest threshold frequency. That means phi is the smallest here. For A, that phi is smallest here. So kinetic energy will be maximum for metal A. So kinetic energy will be maximum for metal A. So this is your answer. Kinetic maximum for metal A. Here the graph is between stopping potential and frequency, and this from this graph for different metals we see that A has the minimum threshold frequency. A has the minimum threshold frequency. That means its work function is small in comparison to the other metal. We know that kinetic energy maximum is equal to Planck's constant into frequency, where frequency is the frequency of the incident radiation, and this is phi. So since phi is very small, the phi of A is the smallest in comparison to the four metals. So kinetic energy will be maximum for metal A. Next question is cell of EMF epsilon and internal resistance R is connected across a variable resistance R, variable external resistance R. The graph of terminal potential difference V as a function of R. That means V is a function of R. So here potential difference V and R. And next the question is a cell of EMF epsilon and internal resistance uh, R is connected across a variable uh, external resistance. So uh, potential difference V, your V is equal to IR. But here your R, but I is equal to epsilon by R plus internal resistance. So V will be equal to epsilon R by R plus R. Now here V will be equal to epsilon R, your R common 1 plus R by R. So V will be equal to epsilon 1 plus R by R. So here we see that when your uh, R tends to 0, R tends to 0, that means infinity. So anything divided by infinity, your V is 0. So that means it starts from the origin. Next, when your R is infinity, so 0, so V is equal to epsilon. And here your graph will be like this. This will be your graph. A uniform wire of resistance 2R is bent in the form of a circle. In the form of a circle. The effective resistance between the ends of any diameter of the circle. This is clearly your effective resistance means equivalent resistance R effective, that is equal to total is 2R. So for half and half it will be 1 by R plus 1 by R. So your R effective will be R by 2. This is your answer. Now a current I flows through a long straight conductor which is bent into a circular loop of radius R in the middle. It's bent into a circular loop of radius R in the middle. As shown in the figure, the magnitude of the net magnetic field at point O. So we know that magnetic field due to circular loop, magnetic field at the center, magnetic field at the center, due to circular loop, due to circular loop is B loop. Let us take B loop, that is equal to nu naught I by 2R. This you have learnt in Biot-Savart law. And magnetic field due to the straight wire, magnetic field due to the straight wire, magnetic field due to the straight wire is equal to nu naught I by 2 pi R. This is nu naught I by. This you have learned all in Biot-Savart law. So this you have learned in Biot-Savart law, and this you get from the Ampere circuitry law. This you get from the Ampere circuitry law. That means you have learned about it. This is a infinitely long straight wire current flowing through it, and if you have to find this magnetic field at point P, which is at a distance R, we consider an Amperean loop, and so Ampere loop, and here that is uh, uh, magnetic field. So your flux, that is equal to nu naught I, the current flowing through, I current is flowing through it, and flux, that is equal to cyclic integral of B dot A ds, B dot ds is equal to nu naught I. So B cyclic integral of ds, that is equal to nu naught I. So cyclic of this is 2 pi R. B into 2 pi R is equal to nu naught I. So B is equal to nu naught I by 2 pi R. This you have learned, and this from the Biot-Savart law. So B net will be B loop minus B wire. So this minus this, you will get the net magnetic field at point O. So here we see that the formula de Broglie wavelength, we know that h by root over 2mk. K is the kinetic energy, h is the Planck's constant, m is the mass of this photon. So here lambda, it is the de Broglie wavelength. So we have to find ratio of there. That means we have to find lambda p by lambda alpha, proton by alpha. So yeah, proton by alpha. So here, according to this, this will be h by root over 2m proton into kp by h by root over 2m alpha k alpha. So here what will happen? Lambda p by lambda alpha So this will be equal to root over 2 m alpha k alpha by root over 2 m proton k proton. So here 2 cancels out, and we know that uh, mass of alpha is 4 times that of proton. So this becomes uh, 4 mp by mp, and k alpha is 1 electron volt and kp is 4. So this all things cancel out root 1. So this is equal to 1. Your answer is 1. We know that when a dielectric is inserted in a capacitor, its um, capacitance that is equal to, when dielectric is inserted, uh, that is equal to epsilon naught A by d minus t plus t by k. This is the formula. When an air-filled capacitor with plate area A and separation D has a capacitance C naught, means this is the original capacitance, that is epsilon naught A by D. This is your original capacitance. A slab of dielectric constant K and thickness T is equal to D by 5 is inserted. So find the new capacitance. So here we know that when a dielectric is inserted in a parallel plate capacitor, the capacitance of the capacitor becomes, this is your formula, this is your formula, and T value it is given to you. So this is equal to C is equal to epsilon naught A by D minus D by 5 plus D by 5k. Now here this will be C is equal to epsilon naught A, don't think it is a bar, by this will be how much, 4D by 5 plus D by 5k. So if you take here epsilon naught A, if you take D by 5 common, so this is 4 plus 1 by k. Now this will become how much? Epsilon naught A into 5 by D 4 plus 1 by k. And we know that epsilon A by D is C naught. So this will be equal to 5 C naught by 4 plus 1 by k. So this is your answer. A biconvex lens of glass having refractive index 1.47 is immersed in a liquid. It becomes invisible and behaves as a plain glass plate. The refractive index of the liquid is. Here the main important point is that it becomes invisible. It becomes invisible and behaves as a plain glass plate. It becomes invisible and behaves as a plain glass plate. What does this mean? Becomes invisible, that means it is, there is no refraction. There is no refraction. That means the light is passing straight through the same medium. Light is passing through the same medium. Light is passing straight in the same medium. In the same medium. That means there is no refractive, no, there is no refraction. There is no refraction. Light is passing straight in the same medium. In the same medium. So let us take the mirror formula. 1 by f is equal to refractive index of lens by refractive index of liquid minus 1 into 1 by R1, 1 by R1, 1 by R1 minus 1 by R2. So there is no refraction. That means it acts as a plain glass plate. So focal length, focal length of a plane glass plate, focal length of a plain glass plate, focal length of a plain glass plate is infinity. It is infinity. So 1 by infinity it is 0. So this is 0. So we get lens, refractive index of lens by refractive index of liquid is minus 1 is equal to 0. So refractive index of lens is equal to refractive index of liquid, and this is equal to 1.47. This is your answer. Means it act as a plain glass plate. That means light is flowing through the same medium, and so it is invisible, moving straight. Light is moving straight in the same medium, and the focal length of a plain glass plate is for a plane mirror, focal length is infinity. So when we take the help of the mirror formula, we find that refractive index of lens is equal to the refractive index of liquid, and that is equal to 1.47. Now my next question is the electric flux emerging out of 1 coulomb charge from Gauss law. It is directly from Gauss law. Gauss law, that is phi is equal to q by epsilon naught. So 1 by epsilon naught is your answer. This is your answer, Gauss law. And two capacitors of capacitance C1 and C2 are connected in parallel. If a charge Q is given to the combination, the ratio of the charges on the capacitors C1 and C2. We know that when they are connected parallel, your potential difference is the same. So your Q1 will be equal to C1V and your Q2 will be equal to C2V. So here your Q1 by Q2 is equal to C1 by C2, because when parallel connection, your potential difference is constant. So this is all about today, for today.